Since I won't be able to hold an official live lesson to review the results of this practice quiz, as I have been doing as of late, I'm just going to attach this video to the end of it so that you can review the answers once you've already finished taking it. So I'm just going to kind of walk through how you solve these various problems that you were asked to do, and then if you have any additional questions, please make sure to consult your teacher. So for this one here, you were asked to find the volume of this triangular based prism. And since this is a review for the quiz, I mean, most of the questions you're going to be asked are going to deal with volume solely. You're not going to be asked much about surface area of prisms, cones. The only thing you're going to really be asked about is surface area of our spheres, or you're going to be asked to, like, if you're given the surface area of one figure and you have another figure that's similar to it, then to figure out its surface area based on other factors. So the volume of a prism is the area of the base times the height. So the height is the 11 inches. I need to figure out the area of the base, and it's a right triangle. So if I could figure out what this other leg over here is, I would have a base height pairing. So I use the Pythagorean theorem to figure out what x is, and I know that x is a 6-inch side, which means that the area of the base is going to be 1/2 6 times 8, because these are the two that are perpendicular to each other. One could be the base, one could be the height, doesn't matter which one's which. And I get that I have a 24 square inch base for as far as the area goes. The square, yeah. The height's 11 inches, as I said before. So now when I do the volume, it's area of the base times the height. So it's going to be 264 cubic inches. For the pyramid's a little tricky because of the fact that here you're asked to find the volume. And you have a square base pyramid, and most of the time that's the kind you're going to get. Square base pyramid, we assume it's a right pyramid. This side here, this 26-foot side, is actually the length of this edge. This edge is not the height. It's also not the slant height. I would need the slant height more so to calculate the surface area. However, the slant height is needed to be known here so I can actually calculate the height as well. So I'm going to find the slant height. And again, since we're assuming this is a right pyramid, then all these edges are 26 feet. And so if I draw this altitude on this face, which is what the slant height would be, it is going to bisect this side. And I calculate the slant height by using the Pythagorean theorem. So L squared plus 10 squared equals 26 squared. L squared would be 576, which means L is 24 feet. I would then use that slant height to calculate what the actual height is. So I then draw this right triangle with the slant height being the hypotenuse. This is a 10-foot side here because we're assuming that this is the center of the square base. And I use the Pythagorean theorem again, and I calculate that the height is the square root of 476 feet. The area of the base is that the square is 400 square feet. So to calculate the volume, I'm going to do 1/3 the area of the base times the height. And if I compute all that together, I get about 2,909 cubic feet. For the cone here, you're given that you have an 8-meter diameter, because it's going from edge of circle to the edge of the circle. This is the height, because I can see that it's measuring straight up and down from approximately the base of the circle to the very tip of the cone. So much like the pyramid we just got done doing, this volume is going to be 1/3 the area of the base times the height. The area of the base is going to be based off of pi r squared. So I have to make sure I know what the radius is, 4 meters. Area of the base is going to be pi times 4 squared, which is 16 pi square meters. And I'm going to do 1/3 the area of the base times the height, or 1/3 16 pi times 12. And I get 64 pi cubic meters, which is approximately 201 cubic meters. for this in here, the cylinder, the biggest mistake I see students make on this particular type of problem is that they oftentimes misassign the height. I'll see students who will say that the height of this is 6 centimeters because they always measure from top to bottom. For a cylinder or a prism, it's the length between the two bases, and that's what the 14 centimeter length here is. This is actually the height of the cylinder. The height does not have to be vertical, and that's where a lot of students sometimes have their issues. They think it has to be vertical. This is the height. The radius is 3 centimeters. So when I do this, I need to find the area of the base times the height. Now the circle, the area of the base is pi times the radius squared. So I'm going to get 9 pi square centimeters. And when I do the volume, it's just going to be 9 pi times 14, or 126 pi cubic centimeters. Spheres, as I said before, the only time, and it's the only one in this particular quiz, you're going to be asked for both the surface area and the volume, or unless you're talking about similar figures, and then you don't have to necessarily use any of the formulas here. What is the surface area and what is the volume? And this is basically just knowing your formulas. Both formulas, though, do involve you knowing the radius. So the radius is 9 centimeters because they're giving you the diameter here is 18 centimeters. The surface area is calculated by doing 4 pi times the radius squared. So I'm going to do 4 pi times 9 squared, get 324 pi square centimeters. The volume is 4/3 pi r cubed. So 4/3 pi times 9 cubed is 972 pi centimeters cubed. This question here, you're given that a container A is geometrically similar to container B. The height of container A is 7 feet, while the height of container B is 4 feet. So they're basically giving you the proportional dimensions of these two similar figures. So they're essentially giving you the scale factor. If container A has a surface area of 21,952 square feet, what is the surface area of container B? Well, since they're telling us that the scale factor is essentially, and I'm doing A to B, that's how I'm defining it here, is a 7:4 ratio, that means that the ratio of surface areas would be the square of this, or have a 49:16 ratio. And since I have container A being 21,952, and container A is, you can see, is the bigger of the two, when I do the surface areas, I'm going to put the 21,152 on top over the surface area of container B. That should equal 49/16. And so I cross multiply and divide both sides by 49, and then I would get that the surface area of container B should be about 7,168 square feet. In the second one, they're saying, okay, well, now the container B has a volume of 343 cubic feet. What's the volume of container A? Well, we expect container A to have a higher volume because it's bigger in size. So, but again, I start with the scale factor. The scale factor is 7/4. The ratio of the volume should be the cube of that. So it should have a 343:64 ratio. So again, I'm going to set the fact that I'm going to do the volume of container A, which I don't know, over the volume of container B, which is 343. That should equal 343/64. And so I cross multiply and divide by 64, and I get 1,838 and 17/64 cubic feet. And every once in a while, they may throw a mixed number at you on the quiz, so don't be alarmed if you see one. But that is the end of this video. If you have any further questions, please make sure to either contact me or your teacher. But until next time, have a good day.